In this question, we have the circuit and we are asked to find the current across R2. We are given all the voltages across the batteries and all the resistance values as shown in the right. We will solve the problem using Kirchhoff laws. We use left and right part of the circuit for our analysis. Let's start with the left part. We take the reference of the battery E1 and draw the current in this fashion. Now we take the right part of the circuit and take E3 battery as a reference and draw the current. You can see that the middle segment of the circuit will have both current I1 and I2. Kirchhoff's first law, which is a current law, is automatically obeyed. So in the question, we are asked to find I1 plus I2. To find the current, we have to apply Kirchhoff's second law, which is the voltage law. Let's do it for the left part of the circuit. I prefer to do it in the following way. I collect all the voltage from the battery to the left-hand side and the current times resistance on the right-hand side. You may wonder how I have the confidence of making the sign right. I refer to the simple circuit of Ohm's law that we learned as a baby in physics, and use the same pattern for the complex circuits. All voltages on the left-hand side and all current times resistance on the right-hand side. This is my style of doing it. Please follow your own style if you are comfortable in a different way. Now let's do for the right part of the circuit. Taking the reference of E3, we collect all the voltages on the left-hand side. Note that if the other battery have a different polarity with respect to E3, we have to make it negative, and all the current times resistance to the right. At this point, physics is done, and it is a matter of solving the simultaneous equation with two variables I1 and I2. We have provided the final answers, but you may like to match with intermediate steps that we have done via Wolfram Alpha software. That is all. Bye bye.